Digital power plants. What can operators of renewable and thermal power plants learn from another to become AI ready? The power industry is facing the biggest transformation in its long and proud history. The secure digitalization of power generation assets, new and old, renewable and thermal, is right at the heart of an accelerated decarbonization of our energy system. Research from McKinsey suggests that via rigorous end-to-end digitalization, thermal power plants can realize an additional earnings potential of 20 to 30%. Thermal plants face significant cost pressure because of renewables and rising emission costs. These earnings improvements are also available for renewable generation, especially offshore and onshore wind. The strong growth of renewables, guaranteed offtake prices, focus on hardware engineering, as well as the relatively short history of large-scale renewable generation are root causes for untapped profitability potential. According to the research, even sophisticated generation players in thermal and also renewables have only implemented isolated digital use cases, lacking significant profit and loss impact, or not improving the way of working rigorously. The business case for digitization also supports achieving decarbonization goals. Digitization can accelerate the reduction of greenhouse gas emissions of thermal power plants. What is a digital power plant? Digital power plants are fully data-centric power generation facilities that leverage advanced software, technologies, and AI with the following objectives. 1. Reduce operations and maintenance cost. 2. Improve the power output and increase asset flexibilities. And 3. Increase the health, safety, security, and environmental performance. They integrate a broad spectrum of technologies, existing and new sensor technologies, OT and IoT devices, AI, mobile and augmented reality devices, drones, robots, and more. The data and information generated is used to improve the planning, monitoring, and control of all aspects of power generation assets. A digital power plant is operational and workflow-oriented. There are overlaps with the digital twin concept, but this is a more holistic approach. Digital power plant and the control room. A key activity of any generation plant is the control room. Operators use this facility to ensure a smooth and safe performance of the plant. The control room aggregates all relevant OT and IT data and information and facilitates real-time monitoring and decision-making. It should be a central starting point for an end-to-end digital power plant journey. Control rooms are sensitive from a security perspective, both physical and digital security. This is an additional advantage because it also enables hardening the existing security mechanisms in place. This is required because the status quo is always challenged by hackers and attackers, and new threats are emerging. New security technologies and data innovations enable utilizing operational systems, control rooms, and legacy IT infrastructure for an end-to-end digital transformation towards the digital power plant. This includes raising current data and cybersecurity levels. But how can this be implemented? Virtual Operations Center for generation assets. Planning and implementing a virtual operations center for generation assets operationalizes the end-to-end digital transformation. It is a digital addition to the existing systems, control rooms, and supports and implements the digital power plant. A broad range of benefits is enabled. 1. Improves the day-to-day control room work and tasks like remote steering, paperwork, optimized inspection rounds, better performance observation, consolidation of multiple assets during operation shifts. 2. Data-driven maintenance planning, such as the ease used to run AI for predictive maintenance, sequencing of maintenance work, spare part and workflow management, and more. 3. Improves overall plant management like real-time asset views, financial impact, people management, consolidated views, and more. 4. Create AI readiness. Reduces the time to AI. Access to data is key to digitize and introduce AI and data access outside the generation asset if often impossible, because of security concerns. This problem is solved because it is based on virtualized data. 5. Track decarbonization performance. Real-time tracking of plant emissions and full audit of data streams. 6. Vendor agnostic and portfolio overview. Data from heterogeneous hard and software environments is released, and different fleets can be aggregated for reporting and steering purposes. How does the technology work? The required software layer resides on top of all existing and new data infrastructure. This enables generators to do anything with data coming from the generation asset, plus data from additional internal and external data sources, for example, energy market data, additional data from hardware vendors, maintenance data, AI, and more, in a highly secure, governed, and trusted way. This includes blending data from different sources, creating new virtual data sets, which feed AI algorithms or can be used for visualization and performance analysis, and more. This approach overcomes the security concerns stemming from the OT and IT convergence. This means moving OT data into IT and sending back commands and data from the IT to OT. It does not require moving data around or building new IT infrastructure and copying large amounts of generation asset data into new data repositories. What are the future challenges for plant operators? Security challenges. Generation assets are an attractive target for hackers and malicious actors because they are critical infrastructure. This has been a long-time key risk for generation assets. One security strategy is air gapping, and there are more. A recent conversation with the CEO of a very big generation company revealed that this has worked so far, but lately they had an attack. The hacker came through a hardware vendor who was connected to the control room. There is no doubt that additional security concepts and technologies need to be deployed in power generation. Flexibility challenges. Another problem is the use of proprietary operational data collection, storage, and analysis systems in power generation. These systems can prevent digital power plants to emerge because they lock up data and make it hard for generation companies to get access and develop additional use cases. Their cost and high vendor lock potential are additional disadvantages. An additional challenge for the digital power plant stems from heterogeneous generation equipment across larger asset portfolios. These come with proprietary data and security systems, leading to the challenge how to holistically manage this portfolio and create synergies. Solutions. The proposed concepts are a great opportunity to address data security and flexibility aspects and achieve improvements in overall data and cybersecurity. Managing and securing the vast amounts of real-time data generated by generation plants of all kinds, as well as managing and integrating older legacy systems, is a significant project. Air gapping was already mentioned as an insufficient security strategy. Pursuing end-to-end digitization triggers reviewing all security-related aspects of the operations and challenging their future readiness. This can also include crypto agility. What are the implications of the emergence of quantum computers for data and cybersecurity? New technologies and innovation. The security and flexibility challenges can be addressed with new technologies emerging on the horizon right now. These are based on zero-trust security models and approaches, reducing the potential attack surface. Unlocking data for additional use cases is the core objective and added value of governed data virtualization. The combination of both delivers unique end-to-end data security and robustness from the generation sensor to the AI. Challenges for generation companies that cannot be solved with technology are cultural aspects and access to a workforce that is familiar with modern OT and IT technologies. Power generation has a long tradition and strong engineering culture that is not software-led. Similar issues can be observed in other industries, such as automotive, where software systems become a key element of the value proposition. The same will happen in power generation over time.